Ready to play? Let's do this. Alright guys, welcome again. It's Vikram Singh and you're watching me playing PUBG. Come on, jokes apart, we're gonna play together. But it's gonna be the AI way. So as you guys can see, I already opened the Google Colab notebook. By the way, in case if you're not aware of what this Google Colab is, then please check my previous video where I talk about Google Colab, or please check the link in the description where I wrote a blog related to this Google Colab. So, and one more thing guys, this video is gonna be different compared to the earlier one, because here we're gonna glaze over throughout whole code what we are doing it. We are not writing the code, because I tried to make a previous video where I try to write all the code. By the way, I'm recording it second time, and that video is probably around more than 2 hours, and if you're gonna watch it, that will probably frustrate you because it's pretty long one. So I'm gonna create a in short version of that video. So in this way we're gonna explain out whatever we're gonna do in this particular whole code. So this PUBG model. So as you guys can see, I already opened Google Colab. So let's go down. And before working on this Google Colab, let's first go to Kaggle and check out what this PUBG model is. Okay. So here we are in Kaggle right now. Kaggle, a learning hub for data scientists. And as you can see, I already signed up to Kaggle using my Gmail account. And it's my super old account. I'm not using it yet right now. So let's directly go to competition section and look for PUBG competition. And here we go. PUBG finished placement prediction. So let's go to this competition and look out a data set and some other information related to this PUBG competition. Let's go down, and here you can see this competition PUBG 1 is launched 3 months ago and it's still a 1 month to go. If you want to participate in this competition, you can go for. Here I am to help you in that particular thing, and I'm going to explain so many things about this PUBG competition that will surely help you to make or to lie among the top. So let's directly go back to a PUBG competition. So here we are. The real learning is about to begin. So before we start working in this competition, let's first go through this outline of this whole video, what we're going to work on. The very first thing we'll work on how to handle that huge size of data set. And to handle that huge size of data set, we're using Google Colab. So first one is done. And the second one is importing the PUBG data directly from Kaggle to a working space. So normally we do what? We first download the data to a local machine, then we upload to a working space, whether we want to work on Jupyter Notebook or Google Space. But here we do what? We directly import data from Kaggle to a Google Colab notebook, and this is a really cool stuff. The third one is pre-processing the training and test data set and check out the available feature set. And the fourth one is take a deeper insight of our data set, like performing exploratory data analysis, ADA, and feature analysis. And the fifth and final one, using random forest algorithm, we create a prediction or we create a model, and over that model we use test data set to create a prediction. So that's what we're gonna do in this competition of PUBG. And the first one is installing the Kaggle dependency. See, we want to import data directly from Kaggle to a Google Colab notebook. And to work on that, to work on the Kaggle API, we have to first install that Kaggle dependency. So let's first install it. And in the meantime, it's running. Let's start some different dependency, like some basic libraries like NumPy, used for matrix manipulation, Pandas for data pre-processing, Matplotlib, C1 for data visualization. So let's run them and move on to the next command, uploading your Kaggle credential. See, you can see upload your Kaggle credential, kaggle.json file. So what are these Kaggle credentials? For that, let's directly go to Kaggle and here go to account section. So let's go down, and here in the API section you can see create new API token. So once you click this button, create new API token, this will generate your Kaggle credential. So what are the uses of this Kaggle credential? I'm going to talk about this in a moment right now, but one thing is that I'm not generating mine credential. Why so? Because I already generated one and I'm using this in my Google Colab and in my AWS. Once I generate a new one, older one got ineffective. So I didn't want to do this because otherwise I have to upload or I have to change most of them. So let's directly back to but you guys just generate these Kaggle credential and upload to your Google Colab notebook. So that's what we're gonna do over here. I'm gonna using my older Kaggle credentials. So let's upload them and run them, and from here let's select the file that's already present in my system called Kaggle, and here you can see Kaggle. Here this one is, and let's upload them. Once it's uploaded, and in the down section you can see Kaggle.json. See, this file is stored username and a key. In case if you guys try to use my credential, don't go for it, because the very moment I finish this lecture, I'm going to generate a new one. So it's not effective if you want to work on them. So work on yours one. So let's check out all the files present in the directory, and using ls command. I think we're already done. So the files like Kaggle.json and sample data. So these two files are already present, and there's a one thing is that if you want to work with Kaggle API, there's a one particular set of thing you have to go for it. So Kaggle API wants you to create an external directory in which you store your Kaggle credential and all the folder, all the data set that you're going to import from Kaggle. All that data is directly go to that Kaggle directory. So that's what we do in the next line of code. We're creating a Kaggle directory, and then we copy the file Kaggle.json to that particular Kaggle directory. In the last line, we call a command called cmod600, and we use this Unix command to secure your Kaggle credential. And that's what I know about it, because it's a Unix command and I rarely work on Unix. Moving on to the next one is copy the Kaggle API. So what is this Kaggle API? For this you need to go to your competition section, and where you can see, not here, at the top, and here you have to go for Pubg again. Let's go to this Pubg, and from there you need to just copy that API key. See, you're gonna find a API key where, it's in the data section. Let's go to data section, and here you can see this API, like here. Just copy this line of code and paste it over here. That's what I do, just copy and paste, and once you run it, it's gonna download all the data or all the data importation from Kaggle to your Google Colab. You will see it's gonna take some time. Now let's again check out all these files present in a Kaggle directory. So here you can see all the files like train, test, and Kaggle.json. All the files are present in that Kaggle directory. Now we do what? You guys can see both training and test file are zipped one. So first we do what? We'll unzip them, and then we read out these files, and that's what we're gonna do in the next lines of command, like unzip train, unzip test, and then we look out for all the file. In the next line of code, we try to read out both training and test files. So let's run them both, and I think it's done. So it's normal process that we are doing. We are just trying to read out these files, and we are trying to see the shape of train, test, and then in the last line of code we see the columns present in the training data set. So in the meantime it's running, let's talk about these feature sets. See, Kaggle dataset has its own specific feature set, and all the columns are called a specific feature set. Our training dataset consists of 29 columns. So all these columns are explained in this feature set. What all these columns are like: assist, number of enemy player, this player damage that were killed by the teammate, like boost, number of boosts are used, heals, ID, kill plays. So all these set of things that generally a player go for while he play PUBG competition are given in this feature set. See, you can see the training shape is like around 4.5 million in 29 columns, while the test shape is around 2 million in 28 columns. And the one column that is missing, that's we need to predict the winning place or prediction. See, in this competition at the top you can see, can you predict the battle royal finish of PUBG player? Means, can you predict the ranking of player? That's we need to create prediction, and that prediction is directly went to the test data set, and that's what we need to create in this PUBG competition. So let's back to PUBG. So the very first thing we do is that check out the different type of data sets are present in train and test. So let's run both of these commands, and this we will find out the integer, float, and there's a different kind of data sets are present for both training and test. So let's go down, and here the real learning thing begins. Finding the missing value present in both training and test data set. See, every column or some columns have some missing value, and we want to do what? We want to find all these missing value, and then we'll drop these missing value. And that first line we find the missing value in the training, and in second when we find the missing value in the test data set. So in the training data set, you can see at the top, You can see there is only one missing value that present in a column called bin place prediction here. So we'll find out that particular row and we'll drop that. So that's what we're gonna do next, and the next line of code we'll find the column or row and we'll drop that row. 27,44,604. So we'll drop that particular row in the next line of code and then check out again for the missing values in train data set. So it's working, and no, now there's not even a single missing value present in the training data set. So the next one is finding the number of matches played in both training and test data set. How do we find this? For that, what if I say, if we find the total number of unique IDs, like every match has its own unique ID. If we find total number of unique IDs present, then we can find the number of matches played for both training and test data set. So that's what we do. We first find the total number of unique IDs and then we encapsulate them in a length function and we get the number of matches played. So let's run them and see the number of matches played in train and test. In the training data set, 47,964 matches played, while in test one, 20,556. So this is both train and test data set. Now next thing is what? Oh, let's code top. And next one is finding the number of players played in each matches. So let's run this command, and now next thing we do what? We create a column. Here you can see some match have is 95 players, like this unique ID match have 95 players while the other one have 99, even some of them have 100 players. So we need to find all these players played in a different matches. So for that we do one thing is that we'll create a new column called players played, and this column store the number of players played in each of the matches. So that's what we do in this line of code. Let's run them. And after that, we're going to create Exploratory Data Analysis, EDA. We'll picturize our data set because picture tells thousands of stories. So that's what we do in the next line of code. We just plot the number of players played in each of the match. So if I run it, and I think here we go. It's done almost here. Let's go down. And here you can see the graph shows that the different number of players played in different matches, and most of the data set concentrated around, I think, more than 85 players. See, some matches have even 100 players, some matches have 98 players, even where there's a very few number of matches which have less than around 75 players. So we need to picturize, or we need to create the data set. The next thing is working on the outlier. So here we have a given match data set. Now we need to find the outlier in this Pubg model. So before that, let's first talk about what are these outliers. So basically, outlier is a data point that deviates the rest of the behavior of data point, like the data point. So here in this plot you can see most of the data point follows that straight line behavior, but there is a one particular point that deviates this normal straight line behavior, and we call that point as an outlier. So we need to find that outlier in Pubg dataset and just remove them or drop them. So let's get down, and now what could be the outlier in a Pubg dataset? See, in Pubg dataset there is one basic strategy called you need to find the player and just kill them. But few players trying to be over smart, they just hide some places and start their killing streak. So we need to find all these players and just drop them. So let's go down, and basic thing, how do we gonna do that? First thing is that we're gonna create a new variable called total distance covered. This way we'll find the amount of distance covered by each of the player, whether he travel or ride or swim. And this way we'll find how much distance covered by this particular player. And according to that distance, we'll see whether this player travel or not, whether this player trying to be over smart, he just hide to some places and start the killing streak. So that's what we're gonna do in the next line of code. So let's go down, and here you can see we have three distances: ride distance, walk distance, and swim distance. And we create a new variable called total distance. And regarding that variable, we just find all the players in train and test data set. Let's run both of them. So here you can see we create a variable called kill without moving, and that variable store all the data set of those players who have more than 0 kills, but the distance is equivalent to 0. So we're gonna do those Same thing for train and test data set. So let's run them, and here you guys can notice that whatever changes we bring in our train data set, we bring the same changes in test data set. So all things are happening at the same time. So let's move to the next one and see how many players playing with the strategy of killing so many players but without moving. See, here you can see it's equivalent true to 1535. So around 1535 players are playing with that particular strategy. They kill the player but they are not moving. Same thing we're gonna do for task data set, finding the number of players who play with that strategy. And here you can see around 1311 players played with that strategy. So we do one thing is that we'll drop all these players out of our data set. So let's run it, and now we're gonna drop all these players. And next from here we drop the outlier from our rest of the data set. First we look out for roadkills, and then we do same thing for the rest of the features. So using roadkills, we find the number of roadkills different players are doing. See, some players have 10 roadkills or 11 roadkills, or there was so much different data set. So we're gonna do one thing is that we're gonna drop all the players who have more than 10 roadkills. So here you can see in the train and test data set, we'll drop all the players who have more than 10 roadkills. So let's run them, and the next one is kills. So we're gonna find out the number of kills, and then we remove or we plot the graph. So let's run all these line of code, and let's look out the plot, what the plot says. So let's go down, and here is the given plot. Here you can see the kills. See, most of the data is that is concentrated around from 0 to 12, you can see that. So we're gonna do what? We're gonna drop all the players who act as an outlier. So we drop all the players who have more than 35 kills. So that's what we do in the train and test data set. So let's drop them. Now I have a question for you guys. Should we remove all these outliers or if not? What's your take on it? And according to me, in data science, there is no specific or predefined strategy through which you can say this one is the right way of doing it. But here you can see I'm dropping so many columns because by just dropping we create a better model, and that better model creates a better prediction. And here we have a huge data set, so I thought we can afford all those dropping of all these rows. So let's move on to the next one, and next one is what? Longest kill. See, some players have a longest kill, so we plot the data set of longest skill for train 1. Here you can see the longest skill is from 0 to 400 meter. So we're gonna do what? We're gonna drop all the player or all the outliers, we just call them outlier, who have a longest skill more than 1000 meter. So that's what we do in the next line of code. We drop all these players. We'll find the number of players. See, here you can see we have 20 players, only 20 players. So we're gonna drop them, and we do same thing for train and test. So let's drop all the players who have more than 1000 meter longest skill. Next one is finding out the anomalies in traveling, like ride distance, walk distance, or swim distance. Initially we take down a one particular variable called total distance. Now we'll take down each of the variable or each of the feature one by one. So first we create the graph for walk distance, and we'll drop all the players who have more than 10,000 meter walk distance. So that's what we do. So here you can see in the graph, most of the data set is from 0 to 500 meter, no 5000 meter, and we are dropping all the players who have more than 1000 meters. So that's what we do for train and task data set. Next we do for plot for the ride distance, like how much riding each player go for. Here you can see most of the data set is from 0 to 10,000 meter. So we're gonna drop out all the players who have more than 15,000 meter ride distance. So let's run them, and next one is for swim one. See, swim distance. So let's run it and create a density plot for it. By the way, here you can see we are creating a density plot using sns.distplot, in case if you are not aware about this particular line of code. So here you can see most of the data set is from 0 to 500 meter. So we're gonna drop all the players who have more than 1000 meters swim distance. See, here we go. Let's find out the shape of the player who have more than 1000 players. See, here you can see there is only 138 player. So we just drop all these players out of a given data set. And next one, we create a plot for total distance. Here you can see we create a plot for total distance of the player, and in that graph you can see most of the players have a data set from 0 to 10,000 meter. So we're gonna do what? We're gonna drop all the players who have more than 15,000 total distance. So let's drop them, and we're just removing so many outliers. The next one is anomalies in weapon acquired, and you guys can notice that I'm just explaining each one of the feature one by one. Now think about it, what if I'm writing all these line of code? That will probably frustrate you because it's pretty long one. So let's talk about this anomalies in weapon acquired, like how many weapons are acquired by each of the player. So first we create a density plot for that, and the density plot shows, so here in this density graph you can see most of the data or most of the players collect the weapon from 0 to around 20, but even there's a few players who have more than 200 weapons. So we do what? We just find out all the players who have more than 50 weapons and we'll drop them out of a given data set. So that's what we do. So first let's find the shape or find the number of players who have more than 50 weapons. See, 135 players have more than 50 weapons. And while I was working in this particular data set, I noticed one thing. Here you can see there's a player who have that particular specific ID, and that player collect 236 weapons. I was like, come on, what do you do with that, buddy? So we're gonna drop all those players from a given data set. So that's what I think it's all done. And the next one is anomalies in heals, like how many heals used by each of the player. So we'll create the density plot, and then we'll drop all the players who have more than 40 heals. Here in this density plot you can see most of your data set is from 0 to 20. So we drop all the players who have more than 40 heals. That's what we do. And the next one is final outcome after removing all these outliers. So what is the final shape of a trained data set after dropping all these rows? So let's check out the final shape. Here you can see 44,43,698 are the remaining rows. While when we begin with this training data set, the initial shape is 44,46,966. So somewhere around 3,000 rows we drop, and which is nothing incomparable to the data set like 4.5 million rows we have. So moving on to the next one is creating categorical variable. So here we're gonna create categorical variable or dummy variable for the feature called match type, and then after we'll check out the final shape of a trained data set. And here you can see the final shape is 47 columns we have. So move on to the next one and look out for the data types in train and test. So let's run both of these line of code, and then after move on to the feature selection. The real thing is about to begin. So what is this feature selection? Let's first talk about this. So basically feature selection is a process of filtering out most relevant feature, and over these feature we train our algorithm or create a model. So that's what we're gonna do. And why we perform feature selection? What are the uses of this feature selection? So think about when we train our algorithm over 47 features, that time the training process is a bit more comparable to the lesser number of features. So feature selection do what? It reduce the number of features. So reduce number of features means reduce the amount of time taken to training the algorithm. That's what feature selection do. And the next thing it reduce the complexity of the model and increase the model's accuracy, gives better predictivity, and also reduce the overfitting. So this is what feature selection do. And the easiest way to go for feature selection is to perform correlation plot. But when your data is more and more complex, or you have a more number of features, that time correlation is not gonna work. So how do we gonna perform feature selection for this Pubg model? So for that I'm gonna using random forest algorithm itself to perform feature selection. How? I'm gonna talk about this. So before performing feature selection, let's take some more cleaning process. So let's first drop kill without moving column and from train and test data set, and then we drop like IDs, group ID or match ID because they have no relevancy with the data set. So we drop all these columns. So let's drop them, and here we import the algorithm called random forest regression, and we're gonna use this particular algorithm to perform feature selection and to train our model. So let's import this random forest regressor from scikit-learn, and then finally check out the shape of train and test data set. So here we go. Here we have 43 columns in the training shape while 42 columns in the test shape, and this is according to the conventions, because there's a one particular column is missing in the test data set, and that particular column we have to predict. And then sample data for training. So we create a sample of 5 lakh rows from a given training data, and we use that sample to train a random forest algorithm, and we perform feature selection on that given sample of data. But why we are doing it, I'm going to talk about this at the very last, so stay tuned to us. Now let's move to the next one, and next one we import mean absolute error. And why we are using mean absolute error, so let's directly go to Kaggle, and here you can see evaluation. And in the evaluation section, it gonna shows us why we are here. You can see submissions are evaluated on mean absolute error between your predicted win place prediction and the observed win place prediction. So mean absolute error is used for evaluating between predicted and the actual value. So we import mean absolute error, and finally we check out the final data set of DF sample, and then we divide the data set into two parts, like Y is the value of all win place prediction, while DF is storing all the rest of the feature except win place prediction. So we create these two new data sets, and after that we split the data set into training and validation data set. So you must be thinking, what is this validation data set? So I'm going to talk about it in the very next line of code. So what is the difference between test data set and validation data set? So let's explain this. So you guys can see in this picture, normally we do what? Normally we divide the data set into training and test data set. So that's what we show in this picture. What is this validation data set? So when we create our model, and before directly applying it to the test data set, we need to check this model, and for that we create a small part of a training data set. We select that small part of training data set, and we call that as a validation data set. So at the top you can see, when we are splitting this training and test data set, we consider the test size equivalent to 3. So it's a ratio of 70% is a training while 30% is for validating. So we're going to use that particular thing. And moving into the next one is random forest algorithm, and we're going to work on this particular algorithm. So before working, let's explain what is this random forest algorithm do. So random forest algorithm is a supervised machine learning algorithm, and it is used for both classification and regression tasks. So here, and this one is one of the most flexible and easy to use, and even without going for parameter tuning, it gives us a better result, and that's why it is highly preferred one. So next thing is, let's explain this random forest algorithm using this chart. Here you can see what is this random forest algorithm. In case if you are aware about decision tree, here you can see there's a one particular tree, and you can compare this particular tree as a decision tree. And when you're comparing number of decision trees, that time we call it as a random forest. And here you can see it's random forest, like it consisting of number of decision trees, like n number of decision trees. And at the last you can see the final prediction of the final classes depend on majority of the voting. So what is this majority voting principle? So basically this majority voting principle do what? Let's read that out for you guys. See, suppose you have 100 random decision tree, and these trees are predicting some 3 unique target like A, B and C. As you can see, class A, class B and class C. Now let's go to the next line. And likewise other 2 target A and B. A is getting higher number of votes. Let's say out of 100 decision tree, 60 trees are predicting target will be A, like 60 trees predicting the class is A, while 20 is predicting class is B, while 20 is predicting class is C. So we take out the majority of all these classes, like A is the majority one. So the final prediction will be what? It's class A. So that's what happened at the very last. The prediction or final prediction is based on majority of the voting. And the next thing is model training. The real job is about to done. So let's go down. And for model training, we first create a model function called score, and this model function prints mean absolute error for both train and validation data set. So let's run it, and in the very next line of code, we create random forest regression. So the number of parameter like number of estimator, minimum sample leaf, or max feature, or number of job. Here you can see number of estimator is equivalent to 40, which means the number of trees we are considering. So here we are considering only 40 trees. To just make our model bit less complex, and the way you increase more and more number of trees, the complexity of model increase, and that much more time it will take while you train this model. So let's train a model over training data set, and it's gonna take some time, so we just have to wait and watch it. And then after we talk about feature importance, so let it happen. Let's talk about the next line of code, feature importance. So here you guys can see we first train our random forest regression, and after that we check out the feature importance. So it's a part of random forest. That's why I say it's a really good algorithm. You just have to do nothing to find out the importance of feature. So here we go. Here you can see mean absolute error for training data set is 0.42. I'm not going to count the rest one, while the validation data set is 0.62. So, and the next thing is we do what? We create a set of feature, or we select a set of feature out of that model. So we perform feature selection or feature importance over this model, and then in the next line of data set we create a new data frame, and this data frame only stores the selected or most important feature. So let's run it. I'm going to talk about it. And the very next line of code, here we go. We create a feature plot, or we create a feature plot according to the importance of feature. Here the real thing, and if you are a player, you have to focus on it. And whether you're a machine learning developer or you're a player, this is for you guys. You guys can see the most important feature in this random forest regressor is walk distance, kill places, total distance, weapons acquired, boost, heals, and longest kill. There was some other feature which have really less importance. So we're gonna do what? Out of all these features, we selected top 25 features. That's what we do in the next line of code. Here we go, I think so. So here we go. Here we select top 25 features out of all. So let's run it, and after that we're gonna print all these features. Here you can see, and we create again a new plot of all these features. So here you can see these are the top 25 features, and over these 25 features we're gonna again retrain our algorithm, and we see what are the main absolute error for both training and validation data set. So let's check that out, and let's go down, and here we select all the features and the columns, and here we're gonna recreate a model using the sample data set. So let's create it, and before that we go through all the process of splitting the data set into training and validation data set, and then we train our model. So let's go through all this process of again and again. Here we still considering 40 trees, like only 40 trees. So let's run it and check out what is the decrement in mean absolute error for both training and validation data set. So let's go top here. While we are performing, initially the mean absolute error is 0.42, and for validation it is 0.62. Let's go down. I think it is done. Here we go, it is done. So here you can see mean absolute error is decremented to 0.038, while the validation is decremented to 0.06, which is really good, because we didn't do anything extra. We just create a new set of feature and we train it. So after finding out the mean absolute error for both training and validation data set, let's move on to the next phase. Training this Pubg model over complete data set, a data set of 4.5 million rows, because initially, if you remember, we take a sample of only 5 lakh rows. So when you train this model over complete data set, there is a one problem you're gonna face over Google Colab, and that's what I'm gonna talk about. So when you train this model over complete data set, this Google Colab gonna run out of memory, because every user have a restricted memory. So let's go down, and for that I'm gonna do what? I'm gonna use some cloud services. You can go for Google Cloud Services or AWS, but I prefer AWS. Over AWS we're gonna use Amazon SageMaker. So here you can read more about Amazon SageMaker, the link in the description, because we're gonna work on Amazon SageMaker in the next video, where we are training a complete model. We are utilizing this complete data, and utilizing this data we find out the most relevant feature, and after that we check out the mean absolute error and see how much the decrement in the mean absolute error once we train over the complete data set. So most of the information related to AWS or Amazon SageMaker will be available in the description. So please go for it. So here we create a first Pubg model over a limited data set. In case if you guys have some question or a suggestion, please leave them in the comment section. And as always, thanks for watching. Thanks for all your support and subscription. Now I need to go to work on second phase, training this model over AWS. So let's go and see you over there.